Okay, so what we're going to do today is we're going to learn how to use the discriminant to determine how many solutions or x-intercepts or roots an equation has. Those words can be used interchangeably, and when we get to the next slide, we'll put all that down. But so the standard form for a quadratic equation is ax squared plus bx plus c equals 0, or if they have it as a equation that you're graphing, instead of the 0 they have a y, so y equals ax squared plus bx plus c. So that's the standard form, and the discriminant is b squared minus 4ac, and that is something you have to memorize. We're going to be using it a lot, so memorize that, b squared minus 4ac. So, for example, we're going to find the discriminant for the equation in A. So first I need to determine what A, B, and C are in my equation. So A is going to be what's in front of my x squared, B is what's in front of the x, and C is the number by itself. So what is in front of my x squared? Nothing, so I assume it's a 1. And what's in front of the B? What's in front of the x? A -2. And then the number by itself is 7, so 7 is the constant. All right, then I'm just going to take b squared minus 4ac and see what it equals. So I take -2 and I square it, and I subtract 4 times 1 times 7. So -2 times -2 is positive 4. 4 times 1 times 7 is 28. So 4 minus 28, the discriminant for this one is -24. Okay, any questions? Okay. Let's take a look at example B. I've got 2x squared minus 7x equals 15. Is that in standard form? No, it's not. So the first thing you have to do is get it in standard form before you do it. Otherwise your signs are going to be messed up. You'll have negatives where you should have positives or vice versa. So get it in standard form first. Alright, so to do that I'm going to subtract 15 from both sides. And now I have 2x squared minus 7x minus 15 equals 0. So figuring out what A, B, and C are. Alexandra, what's A going to be? Just what's A? Okay. And Farah, what's B? Yep. Adon, what's C? That's right. Okay, so I plug that in, b squared rather, so -7 squared minus 4 times A times C. So if I multiply that out, that's 49. And then because I have a negative times a negative, this becomes positive. So that's something you want to watch out for when you're doing these. So pay attention to your signs. So 4 times 2 times 15 comes out to 120. And so if I add those together, I get 169. So the discriminant for that one is 169. Okay. Any questions so far? All right, so I'm going to let you guys do this one on your whiteboards. First thing before you do anything, oh, actually, no, my bad, this one's for notes. Sorry, there's one more for notes. Okay, all right, so let's take a look at A, B, and C here. Okay, A is what's in front of x squared. What is in front of my x squared? A 4. Is there a term with just an x? No. But I have a constant, a number, so my C is -25. So what does that mean B is going to have to be if it's not there? A 0. Okay, so whenever a term is missing, its coefficient must have been 0. So we put in b squared minus 4ac. And so I get b squared, 0 squared, minus 4 times a, which is 4, times c, which is negative 25. And so I have, again, I've got a negative times a negative here. And 4 times 4 times 25 comes out to 400. All right, now this one you guys are going to do on your whiteboards. First, show me, before you do the whole problem, show me A equals, B equals, and C equals, so I know you're doing it right. All right, so we all agree A is 3, B was negative 9, and this time C was missing, so C was 0. Now plug it into B squared minus 4AC. Okay, so you end up with 81 minus 0, so it equals 81. Alrighty. Let's do this one also on your whiteboards. Is it in standard form? No, it is not. Put it in standard form first, please. Okay, so we all settled on negative 5x squared minus x plus 2 equals 0 as our standard form. So A was negative 5, B is negative 1, C is 2. So negative 1 squared minus 4 times negative 5 is positive 2. So what happens to my signs there? I have negative 4 times negative 5, it becomes positive, right? All right, so negative 1 times negative 1 is just 1. And we end up with 40. So the answer is 41. Okay. Alrighty. So now we're going to talk about what it means if the discriminant is negative, what if it means if it's 0, or if it's positive. So let's just start out with if the discriminant is negative. If the discriminant is negative, then there are 0 roots. Okay? The word roots can be used interchangeably with solutions or x-intercepts. They're all the same thing. The roots, solutions, x-intercepts, they're all the same thing. So if there are 0 x-intercepts, is the graph ever going to touch the x-axis? No. So when you have 0, or when you have a negative discriminant, that means the graph does not cross the x-axis. So when we graph x squared graphs, you get what's called a parabola. So it looks something like that. So if the discriminant was negative, it means my graph is either up in the air there above the x-axis, or it could also be down here below the x-axis. But either way, it's not crossing the x-axis at all. If my discriminant is 0, then that means that there is 1 root. So when it's 0, there is 1 root. What that means is the vertex is on the x-axis. So when I graph it, means it comes down and just touches the axis and then moves away. The other thing that's true is if it's 0, it can be factored. And it's a perfect square trinomial. Okay, so for example, a perfect square trinomial, it would be something like y equals the quantity x minus 3 squared. So when the discriminant is positive, that means that there are two roots. It's positive, there are two roots, which means it's crossing the x-axis 2 times. So the graph could look something like this. And you can see where it crosses the axis 2 times. If it's positive and it's a perfect square, that means you can solve by factoring. If it's positive and it's not a perfect square, then you're going to have to use completing the square. So you're going to have a radical in your answer. Now, even if it is a perfect square and you want to use completing the square, you can, but it's going to be faster to factor it. So the only time you have to use completing the square is if it's positive, but it's not a perfect square. Any questions? Alrighty, that's all I'm teaching you today. We'll learn more about it at another time. Without looking, let me blank this out. All right, without looking, if the discriminant is positive, how many roots? How many, everybody?
2.
If the discriminant is 0, how many roots? 1. If it's 0, how many roots? 1. And if it's negative, how many roots? 0 roots. Because we can't take the square root of a negative, can we? And eventually that b squared minus 4ac is going to be in the quadratic formula. So that's why. Alrighty. You guys are good to go.